I'm changing this to 2 dimensions. You can't? No, you can't. Yeah. Timeout. I'm changing my first function to accept a 2-dimensional array as a parameter. Why is there a squiggly?
Because you didn't put anything
I don't need a comma in between there. Oh, you didn't say comma, you said column. If I put a number here, let's say my array down here, I'm going to go nums. I want 2 constants now. So let's really mess this up. I'm going to put rows, and we'll do another constant, cols, and we'll say 2. Okay, so I'm going to come up here, and I can put rows and cols in here, but all I have to put is just the cols, right?
Yeah.
Why?
Because you just have to know how many sections.
Yeah, but why do I need to put columns if I don't need to put rows, Mark?
Because if you don't, then it'll only be 1 dimension.
No, it's 2.
Because it's put 2 ways.
Why do I have to fill in the column space right here, but I don't have to fill in the row space?
Did you put a default in the parameter in the first time?
Why do I have to fill in the column space but not the row space?
You have to know how many columns there are to see how many spaces.
Does anybody know? Gabby.
The compiler has to know like how many spaces it needs for the rows.
It does. An excellent answer. She said, if I don't put this, it's not going to know how many are going to take up a row. So if I can put cols here. Is the compiler going to like it?
No, because it's being defined after.
Yeah. So I've got to move these up. Up here. Now they'll like it. So I could, if I want to, put rows here. Don't have to. It's not a bad idea to do that, though. So I'm going to say, all right, rows and, no, not that, but this, columns. And same thing down here. And I'll probably put the constant back in here. Okay, and I've got rows. What always comes first, y'all? The rows. They're always in this first slot here. All right, and then just an int. So there's my prototypes. Let's say I've got nums, and I want it to be rows big, woes, rows. Let's put the caps lock on. Rows, and then cols. We'll take out size because it's not there anymore. All right, we're going to do the same thing with a 2D array here that we did before. Get nums. Does any of this change? No, main stays the same except for my array declaration. So down here, I've got the same kind of thing. Nums. We'll worry about these loops here in a minute. I better worry about them right now. Enter. Ooh, what's this got to be now? If if I've got 5 rows and 2 columns, how many elements are in my array? 10. So I could put rows times cols.
Well,
Now, what about my loop?
You do rows in one loop, and then inside of that put another for loop.
You're exactly right. For every dimension, I need a loop. So I suggest use at least R. Don't leave it X and Y, please. When we're talking about 2-dimensional things, or 3-dimensional things, or 4-dimensional things, or 5-dimensional things. Rohan said earlier, really before class started, he said, well, what about a 4D array? What could that even be? Since I don't think in 4 dimensions of space, I don't know, some of you all at your home planet might, but most of us don't. Okay, Gracie does. Well, it could be, let me get a little whiteboard here. What if, we'll go with Bell Blue here. What if I've got this apartment building? And it's got maybe 3 floors on it. It's kind of a dilapidated apartment building. So here's the door. And then it's got apartments in the front and the back. So how many apartments does this have in all? Well, it's got, oh, maybe it goes like this too. Maybe I'm cramming people in there like crazy. So each little block here is an apartment. How many apartments do I have? So I've got 2 going this way, and I've got 2 going this way, and I've got 3 going up. So if I were going to make a multi-dimensional array out of that, it would have, if we call this rows, it would have, well, that's probably rows, but if I call this columns and this depth or something, then I could have that right there. And okay, that's 3D, and we can visualize that. Well, what if I made another one of those over here? Maybe I'm branching out, and I'm going to be a slumlord in different parts of the city. Now, could I have a 4-dimensional array that has, as one of the dimensions, which building I'm talking about? See, I could say what floor, I could pin down any of these things in here based on 3 dimensions. But now, if I used a 4th dimension to say, okay, which building? This could be building 1, and this could be building 2. So I could use 4 dimensions for that. But still, I'm in 3 spatial dimensions. And then I might have a 5-dimensional thing that says, what city are these things in? So I can use dimensions in a bunch of different ways. They don't have to be just in terms of what our minds can conceive of. Okay, so thinking about that, I could have a bunch of dimensions over here. But for right now, let's just go with these. Okay, so I've got this, and then I need to do another loop for int c equals 0, c less than cols, C++, our favorite language of all. And then we're going to do cn.
You need to change size to rows.
Yeah, thank you. Good call. It's rows. Okay, so that gets rid of squigglies. So I can say nums are, remember rows always come first, C. Now notice again, my array is the parameter, but I'm changing the array because I'm being sent the address of the first element in the array, which is what? Row 0, column 0. Now in memory, this array is laid out just as one long stream of ints. In other words, if there's 10 things in there, six, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In memory, it would look like this. It would be prettier, of course, but it would look like this. Now then, that's why I have to put how many columns, because here's 0, 1, 2, 3, 4, and then right here is where my next row starts. So this is spot 0, 0, row 0, column 0, and then here's row 0, column 1, and so on, and then this is row 1, column 0. But in actual RAM, they're just a line of memory. They don't have 2 dimensions in RAM because RAM's 1D. So this would be row 1, column 2. And so we go back to here, and look what it's saying. When the row is 0, then I'm going to fill up the columns first. So it's working its way across. It's working its way across this way. The row stays 0 all the way across this. Row 0. And then over here is row 1. All right, so you go back at your code, and that's why we nest these loops like this. If I had 3 dimensions, I'd have another for loop going on. Okay, stop right there. Anybody going, this doesn't make any sense at all? You lost me with the flat people. Does it make sense? If it doesn't, say something. If you read it, it helps that this is not your first exposure to it. What am I going to do with this get largest thing? Man, oh man, that's going to take a major rework, isn't it?
You do another 2.
Yeah, I could just take, well, largest is going to be what? Num's what?
0, 0.
Yeah, let me copy my parameter here so I don't have to type. Still just going to send back one of them. Largest is nums, like y'all said.
Forgot to delete the last bracket.
Okay, thank you. I'll just move it down here where I needed it. So now we're saying the first thing in there, the first one's still king. So that's 0, 0. How do I know that? Well, this excellent drawing over here tells me that that's the first one there when you think about it lined out in RAM. And so I'm going to take this out because I sure don't want that changing. I think we put a constant back in here. Now what? Well, I can just take these right here. And replace that. So now then I'm going to work my way through the array. If nums are C, though, is bigger than largest, then this equals nums are C. And then down here, I can just print them out. So I can take my 2 loops again. The array is, and so I'll say this. We're going to have to modify this a little bit. So let me get my heading again, my parameter out of it. Now I want big still there. Okay, did I leave too much stuff in there? No. The array is, now then I want to print this out in a nice, neat form. If I just do this, what's it going to do? Let's see. I mean, it looks like it's going to compile. Let's try it. What's the worst that could happen? That. What's it saying? Oh, X. So R, C. Brenna.
All right. 21, 13, 17,
You're in a very odd mood today.
18,
Oh, there you go. Okay, all right.
33.
Now, when I enter 33, what just happened? I got all the way across the first row. Now we're starting on the second row.
27,
Yeah, we're back to odd again.
42, 45, 56, and 36.
Now notice this largest, thank you, Brenna, this largest thing worked. 56 is the largest one in there. But it's printing them out like it was a 1D array. Well, let's see if we can fix that. So I go back in here, and what do I want to do? I want to print one row, which means I go all the way through this column stuff. And each time I print something, I don't want to put an indel there. What might I want to do? I might want to say, well, I want a field width in there. Yeah, that's what I want. If I'm going to put field width, what do I need? Up here. Yeah, thank you. Include. See, that early stuff comes back to haunt you. I'll manip. Okay, so I'm going to come down here, and I'm going to say, I want to print this out, but I want a field width. How do I do that? Set W. Now, if I'm going to enter pretty small numbers, I might just say set W4.
Well, wouldn't you want to do it the number of rows?
So when you see this, it'll make more sense, I hope. So I'm going to print this out, but I'm not going to print an indel. I'm going to end my C out right there. Now then, that's going to print a whole row. Well, let's run this. Let's let you see this. It's not going to look. Go ahead.
An endel after the loop.
A what?
An endel after the loop, because otherwise then it's going to print the largest is on the same line.
Yeah, so we'll do this. Okay, so let's run it. Brenna?
9, 8, 4, -2.
Oh, man.
Yeah. 11, 21, 14, 17, 18, -7. Yeah, there you go.
Thank you. Now, it kind of flips. See, what would I want? I would want my first row, which ends right here. What do I want right there? An indel. So how do I put that? That's after it's printed out. Think about it. It's after it's printed out all the columns in that row.
So you put it after the for loop. No, you put it after the.
Yeah, watch what I got to do. I got to put a curly brace here. And then I got to come down here and say, okay, after you print out all the columns, remember this for loop runs what? 5 times for every one of this loop. So I put an indel here. It is, but we live in a crazy world. Now see, I'm printing out all the columns, and then I print an indel, and then I go back up for the next row. So let's try this one more time. And we'll go to our number girl.
15.
That's where that 15 went.
34.
Uh-huh.
81.
Uh-huh.
-12.
Oh, sorry.
100.
Wow. You're pushing the envelope. Go ahead. That's okay.
Okay, 13, negative 120, 35, 42. Yeah.
Now see, it worked, but we had our spacing at 4, and that negative 120 took up all 4 of those spaces. Otherwise, if this had been like a smaller number like these over here, then the spacing would have been, each column would have been right justified. So that's fine. And the largest is 100. So all we need to do to fix that is go in here and maybe make this 6 or 7 or something. But you want to make your columns justified. Okay, stop right there. Anybody? Something not making sense?